Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shen, coming to you live from Summit Academy. In this video, picking up where we left off, working on that Unit 5 study practice. And so in number 7, it says to study the equation. And you're going to have, and notice that it is that exponential function, meaning we have the variable in the exponent. So that means, again, make sure you're thinking we have log and exponential are inverses of each other. As long as you can kind of remember that way you can kind of switch back and forth between those two. So that way it's an easy way to get your answers. So for this one, I'm going to write this in terms of log. And so what I can do is this. I can take the log of both sides. Again, notice, or maybe even write for yourself, I can say my base is 8. My answer is 19. And my exponent, let's do it in yellow, exponent is x. So again, make sure you're checking out that previous video so that way you can kind of use these three to be able to build your equation. So let's do orange maybe. How does that look? Yeah, perfect. So I'm going to take the log of both sides and I'm going to use my base 8. So I have log base 8. My answer is 19 and my exponent is x. And so again, be able to calculate this for yourself. And so what I'm going to do now is I'm going to say, okay, in your wonderful graphic calculator, I can take alpha window 5 and you'll be able to pull up this log. So alpha window 5 have log base 8 of 19 and I need to round it to the nearest hundredth. So I'm going to say, okay, in my answer, so let me have in my answer, I'm going to have x equals 1.415. Since it says hundredth, that's the second decimal place, and so I need to say, okay, if I'm looking to round, I underlined the hundredth column, I circle the adjacent number. If that circled number is 5 and above, I round up. So now my rounded answer is going to be 1.42. Again, please be careful on those values because if you round it incorrectly, your answer is going to be incorrect. Okay, moving on to the next one. It has for number 8, gives you an exponential function. So it says study the function as 17 times 0.7 to the power x equals 51. Solve for x and round to the nearest hundredth. So again, let's do some setup like this. And so what I'm going to do is actually I have 17.07 the power x equals 51. Let's write that a little bit better. 51. And I'm going to do is this. I'm going to use my inverse operations to be able to solve for x. First step, I'm going to divide both sides by 15, not 15, even though I wrote it. I'm going to divide both sides by 17. And so now I can say, all right, divide both sides by 17. I have 0.7 to the power x equals, and then 3. Again, make sure you can rewrite it for yourself. I can say I have log, so let's say log base 0.7. My answer is 3. My exponent is x. Again, make sure you type it in carefully. So let's go back to our wonderful calculator. Alpha window 5. I'm saying I have 0.7 as my base, and in parentheses I have 3. I should get a small answer, and I do. So I'm going to say for this one, I'm going to say x is going to be equal to, was that negative 3.08. Let me double check on that value. Yeah, it looks good. For that next one, and number 9, there it is. Number 9, it says study the equation. It gives you same kind of setup as the previous one, and so I'm going to have my equation 147 equals 3 times quantity 7 to the power x minus minus 5. And anytime your exponent has a variable, that's when we're going to have that, oh gosh, that's when we're going to have that exponential function. And so that means we need to change it to a logarithmic. That way it's easier to evaluate. Logarithmic. Sorry about the sloppy handwriting, still getting used to it. Okay, so I'm going to, let's do this. Should be able to divide both sides by 3. So let's double check. Where's my calculator? Okay, so I have 147 divided by 3. So I have 49. So let's say I have, do my inverse operations. I want to double check the answer. So I do divide both sides by 3. And so now I have 49 is equal to, and I have 7 to the power x minus 5. Make sure we're still on. Looks good. Alright, so now if I look at these two, I need to take a log. So I need to take a log of both sides. So I have log base 7, excuse me, log base 7 of 49 is equal to, and then I have log base 7 of 7 to the power x minus 5. Anytime you have that log to the same base, and let me highlight what I'm talking about. I'm talking about this. So if I highlight, I say, hey, anytime I have this situation where the log of my value is the base, that's just going to equal 1. So let me say this is going to equal. Let me write it like this. So this is going to just equal 1. And what I can do is I can move this exponent, here to the front. And so let me do that. So let me try to select, let's see if I can use this high power technology. It might be a little bit too much. Yeah, let's do, can I select just down here? Still no. All right. So what I can do, let me rewrite it. Again, I can move this exponent to the front. So move to front, and that's still multiplying. Okay, so let me have it what I'm talking about. Let's have log. Let's do that one on the side too while we're at it. I have log, so alpha window 5. My base is 7. My answer 49. My answer, or my result, should be 2. Yep. And so I have 2 is equal to, and now I have x minus 5. And we said this all goes to 1. So I can say this equals 1. So that's why we can kind of cancel it out. So now I have a real simple one-step equation. X minus 5 equals 2. So I can add 5 to both sides, and I end up with 7 is equal to x. And the nice thing too is this, I can go ahead and plug this into my original equation and check it out. So I can take and plug that back into, oh Lord, my original equation. So let me do that. So let's type it in. I have 3 parentheses 7 to the power of 7 minus 5. Okay, I typed it in exactly as it looked, except instead of x, I now have 7. I end up with my answer on the left side, so I know I am good. Always make sure you can check your answer so that way you are confident in your abilities. So it says study the equation. I have 6 to the power of 5x equals 13. That says rewrite the equation to solve it for x exactly. And so I'm going to notice how it has log base 10. So let me follow what it's doing. So I'm taking log base 10 of both sides. So I have 6 to the power of 5x equals log of 13. again, our exponent is moved to the front, and so I have 5, let me do in white, make sure we don't lose our place. So I have 5x, I'll write that separately. So I have 5 times x times log of 6 equals log of 13. The reason why I'm writing them in different parentheses is because I know they're all multiplied together, but I want to make sure I can kind of get this x by itself. So what I can do is this. I can divide both sides by 5, divide both sides by log of 6, and so I'm dividing both sides by 5 log of 6. And so I can say my answer, whatever that value is, my answer should be x equals log of 13 over 5 log of 6. And so we can pick D for that choice. So again, make sure you're very careful. Notice how the small changes between each of these answers. They are very similar, but I can set it up to answer it carefully. Moving on to number 10. Number 10. How about number 11? It says Mr. Shank's car was originally stolen, RIP, in September 2022. The retail price was $16,000 at the time. Their car loses value at a rate of 31% every year. So part A, write a function that will represent the value of the car after t years. Part B, what will the value of the car be in 2025? And when will the car be worth 25% of its original value? Show your work. So got a couple parts of this, and so let's break it apart one step at a time. So I'm going to do this part A first. So anytime I have our functions like this, so before I do that, let me do copy, paste, in case I need a new one. Okay. So anytime we have these rate problems, again, this is going to be exponential growth or decay. And so the parts that you need from it are this. I'm going to say this is my, let's say my function. So my function in terms of t. So I have whatever the total amount is going to be. I have my time in years. I'm saying this is equal to t sub 0, and this is my starting amount, or it's called an initial. It's kind of like your initial in your names. Okay, so I have t sub 0, so that's going to be my initial amount, times 1 plus or minus r to the power t, where r is going to be the rate as a decimal. And you're probably wondering, why do Mr. Shank, why do I have a plus or minus? Well, the plus goes with growth, and the decay probably goes with your minus. So that just means that depending on your situation, so for like this one, since I'm talking about that it loses, I know there should be only one s in there, since it loses value at a rate 31% every year, that means I'm going to have minus. So let's kind of set this up. So let's do like this. So make sure, again, you have these in your notes, jot it down on the side if you need to, but I'm going to start fresh. So I'm going to say this. I have, what do I need? I need that my rate R is going to be 31%. So I have 31% is the same thing as 31 over 100, which is 0.31. I have t sub 0, meaning my starting price is going to be 16,000. And That's basically all we need for right now. So now when I go to rewrite my equation, so for part A, I'm going to say my equation. So let's say my car, so let's say C in terms of t. So my function C in terms of t is going to be equal to, so I have 16,000, it's my starting price, times, and I have 1 minus r, because we're talking about loses. So 1 minus r is going to be 1 minus 0.31, which is 0.69. Nice. And so I'm going to say 0.69 to the power t. So that's going to be our function for this one. So now in part B, so we did this one, so now we're going to this one. Part B, what is the value in 2025? So be careful again, we're not saying this is equal to t, we're saying our t for this one, so for part B, so let me write it, I can write it over here maybe. Part B, we're letting t equal 3. Again, be very careful on that one. I've seen a lot of people put different values in there, like 2000. Make sure you're just saying it was a change from 3 years. So now I can say, well, let's have this. Let's have t equals 3. So I'm saying C, my total cost after 3 years, is going to be equal to 16,000 times 0.69 to the power of 3. So type it in exactly as it looks in your calculator. So I have 16,000 times, so parentheses, 0.69 to the power of 3. Hit enter, get your value. So I'm saying the value of the car is going to be,
sorry for the interruption, high school. So
my total price after 5 years, or not 5 years, after 3 years, let's say, is going to be $5,256.44. So I'm saying that this is going to be my general equation. Part B is my price, and so now part C is where we're going to be at. Close it out. So we're saying part C is this. It says when, meaning we're solving. So this is solving for t now. We're saying it's going to be 25% of its original value. So 25%, what does that mean? Well, I can take 0.25 times 16,000 to get 25%, and so that's going to be 4,000. So it's saying this. It's saying, okay, it's saying C of t is now 4,000. So we're saying, okay, how many years is it going to take? And so we say this is equal to 16,000. And we have times 0.69 to the power of t. So we're solving for t. So make sure, again, you can have this set up. And so I have divide both sides like we did in those previous problems. Divide both sides by that amount. So divide by 16,000. And so now we have this is equal to, I have 0.25. 0.25 is equal to, let me draw an arrow like that, and say 0.69 to the power t. So I'm saying, okay, how can I get this? Again, a lot of people are like, yeah, just take the square root because I have an exponent. That's not the case. You have to take log. So take log, let me write that down, take log of both sides. So I'm going to take log base 0.69 of both sides, because if I take log of 0.69 of my right side, again, remember the t comes down, my exponent comes down, and that amount, it ends up being 1. So I am going to have this. I'm going to have t is going to equal to, So our time in years, we have alpha window 5. Our base is 0.69 and our amount is 0.25. Hit enter, and so it's going to be about, let's say, about 3.74 years. So again, be careful when you're rounding. Again, we can say it's about. If you wanted to say 3.8 years, that's fine. But these are going to be our 3 answers for these problems. Again, make sure you're noticing it's a multi-part problem, so you have to have those 3 answers. You want to make sure you're supporting your work using that space provided. For number 12, it says, in a hypothetical situation, a new bacteria-based virus was discovered 7 years ago. In 2015, the number of cases was 7,488. However, in 2022, the number of reported cases grew to 86,853. Write a function for the exponential growth of the bacteria virus using these 2 values. So it's saying, hey, at b of 0, it's this amount, and after 7 years, it's that amount. So what we need to do for this one is we are solving for the part that we don't know. So the part we don't know is 1 plus r. Again, it's growth because the values are increasing from start to end, so we know it's going to be growth for the situation. So again, we can say it like this. We can say, all right, we have b of t is going to be equal to our starting amount. So we have 70,488 times, again, we have 1 plus r because we don't know what that is, the power t. Or, excuse me, not the power t. We have, the power t. Again, we need to solve it, so what we do is this. We say, okay, well, when t equals 7, it's this amount. So what I can do is this. Use b of 7. So I'm going to say this amount on my left side. I have 86,853 is equal to my starting amount times 1 plus r. Again, we don't know what the rate is, but we know that it's set up like this, and t for the situation is going to be 7. Again, I know in the original problem it should say 10, but we'll just stick with 7 to change it up a little bit. So now, what are we going to do? Well, we can take the log of both sides. So I'm going to, or actually, let's divide first. So I'm going to divide both sides by that coefficient. Divide both sides by that coefficient. A little bit too many on that first one. Let me erase that a little bit right there. Okay. So I'm going to divide both sides by 70,488. So 86853 divided by 70,488 is that value. And what I can do, so let me write this down. It's gonna, because I want to use that entire amount. So I have 1.23. Let me double check again because I'm switching screens. Yeah, so it's 1.23, but I have values after it. So I'm going to say dot 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 is equal to, and I have 1 plus r to the power of 7. Please make sure that you are using this value that is in that calculator. So I'm going to highlight it, kind of show. Again, you want to use that entire value, otherwise it's going to give you different answers. Now that we have our equation set up like this, what we can do is actually, instead of having to use log or anything like that, we can actually, since we have our value in our exponent, we actually can take the root. So let me actually write that. Let me write that down. So since we know the exponent, meaning non-variable, can take the root of both sides. So again, be careful when you're doing this, because you want to say, hey, I need to take the 7th root. So this is what I'm going to do. I'm going to say, okay, I'm going to take not the square root, not the cubic root. I need to take the 7th root because that is my exponent. And so you're probably wondering, how do I do that on the calculator? Well, I'm glad you've asked. In your calculator, you want to hit, again, in your line, I want to hit math, and then I hit, or scroll down to 5. I notice how it has my radical symbol, but I don't have the value there because it's an x. And so I'm saying, okay, hey, I need to take the 7th root. So I type in 7, and instead of having to type out that entire 1.23 all of those values, I do need to use those values. But what I can do is I can say, hey, in this spot, I want to do second negative symbol, and it's going to pull my previous answer. So if you're ever unsure what your previous answer is, you just hit up on the arrow key, and it will say, hey, this is your entire answer, so that's what it's going to take the 7th root of. I hit enter, and that's going to be my answer. So I'm going to say, like this, let's say, go back, I'm going to say, okay, I think it was 1.03, yeah, I'm going to say it's going to be about 1.03 is equal to 1 plus r. And so this is helpful because when we go to write our function, so again, make sure, again, don't circle this as your answer. We need to write that function. So we're going to say, and set it up like this now. So let me kind of highlight what I need. So instead of this part, we now have 1.03. So I'm going to write my final equation on the side here. I have b of t, meaning our function b in terms of t is equal to our starting amount times 1.03 to the power of t. That's going to be our entire function. So again, make sure that you're using that graphic calculator to get your answers. Be sure to ask questions, and as always, super slam that subscribe button.